Hello and welcome to lesson 8.5 where you guys are going to be learning about analyzing decisions. And for this we're just going to jump straight into an example. Here's our one and only example. A test for a virus correctly identifies someone who has the virus by returning a positive result 99% of the time. The test correctly identifies someone who does not have the virus 99% of the time. It is known that 0.5% of the population has the virus. A doctor decides to treat anyone who tests positive for the virus. Is this a good decision? Lots of stuff there. So, in any of these problems, we're going to set up a chart. And we have to figure out what we're going to put into each piece of this chart. Automatically, we know that we have a total. That's always going to be the last column and the last row. We have some sort of total. And I'm going to start with that. It is known that 0.5% of the population has a virus. So I've got a couple of things that I'm looking at here. Someone who has the virus and someone who does not have the virus. So those are going to be two parts of my chart. I can put them here or I can put them here. It does not matter. We will all get the same answer in the end. So I'm going to go ahead and put it here. So I'm going to put in those who have the virus or has the virus and does not have the virus. So, those are going to be the two pieces of part of our chart. The second part is a positive result and a negative result. Those are two other pieces that we are going to be dealing with. So, in my chart, I'm going to put those in the missing pieces. So, either those that have a positive result or a negative result. This is going to be the hardest part of creating these types of problems, is setting up the chart. Once you have the chart set up, it's going to be pretty easy from here on out. Now, in this problem, I don't have a number of people. It's not given to me, so I'm going to choose whatever number of people I want to. It could be 100, it could be 1,000, it could be 1,000,000, and no matter what number you choose, we will all get the same answer. So it's not a problem if one person chooses 1,000,000, one person chooses 10. But for this problem, I'm going to go with a big number. I'm going to choose 1,000,000. So that's going to be the number of people that we're testing. Now, in this problem, it is known that 0.5% of the population has the virus. So out of all of the population, 0.5 have the virus. So I'm going to go ahead and put 0.5% in here. I want to turn that percentage into the number of actual people. So what I'm going to do, total that has the virus. In order to turn that percentage into the number of people, what I'm going to do is I first need to turn that percentage into a decimal. So all I have to do is take that decimal and move it to the left twice. So I have 0.005. And then I just take that times the population. And when I multiply those two numbers, I'm going to get 5,000 people. So, 0.5% of 1,000,000 people is 5,000 people. That's how many people have the virus. Now, how many people do not have the virus? Well, all I have to do is look. Overall, there's 1,000,000 people that are in this test. So all I have to do to find out who does not have the virus is take 1,000,000 and subtract 5,000. When I do that, I'm going to get the number of people that do not have the virus. When I subtract those two numbers, I'm going to get 995,000 people. So that's how many people do not have the virus. So I filled out the last column of our chart. Now what about the rest of it? That's where these other percentages are going to come into play. This first percentage is someone who has the virus by returning a positive result. So has the virus with a positive result is 99% of the time. So I'm going to find that spot that has the virus and a positive result, and I'm going to put 99% in that spot. The next one, someone who does not have the virus and a negative result. Does not have the virus and a negative result. So I'm going to find where those two boxes are together, and that's going to be in this spot right here, 99%. Now once again, I want to turn these percentages into actual number of people. 99% of 5,000 has the virus. So what I'm going to do is I'm going to take 99%, or 0.99, once again we're going to take the decimal and move it over twice to the left, times the number of people that we have. 5,000 people have the virus. When I multiply those two numbers together, that is going to be how many people I actually have the virus and a positive result. That total is going to be 4,950. So up here, 4,950. Once I have that number, it'll be easy to find this number. There's 5,000 in total. Part of it is 4,950. All that's left is 50 people. So all I had to do was take 5,000 minus 4,950, and that's what I'll put in that last spot. Now this next one does not have the virus. In order to figure out who does not have the virus and a negative result, we're going to do exactly like what we did above. We're going to take 0.99, because that's the percentage we're dealing with, is 99%, times the total number of people that do not have the virus, 995,000 people. So times 995,000. Once we multiply that together, that will give us the number of people that do not have the virus and test negative for it. So that number is going to be 985,050 people. 985,050 people. Now that I have these two pieces filled out, I can easily find this spot right here. I know that my total is 995,000. I know that 985,050 people are in this spot. So all I have to do is take my total minus this number, and that will give me the number of people that will be in this space. When I do that, I'm going to get 9,950. Now we've got two more spots to fill out. We want to know the total number of people altogether in this column. So all we have to do is add these two numbers together. When we do that, we're going to get 14,900. Same with this one over here. All we have to do is add these two numbers together. And when we do that, 985,100. So now we've got the chart filled out. Now we can answer the question. The ultimate question we want to ask ourselves is this. A doctor decides to treat anyone who tests positive for a virus. Is this a good decision? Well, we want to look at what is the percentage of people who test positive for the virus. So here's the positive result. The total number of people that get a positive result is 14,000. So I'm going to go ahead and type that number down here. 14,900. So I'm going to type 14,900. The number of people that actually have the virus after they've been tested, they actually have the virus, is 4,950. So those that actually have the virus is 4,950. I want to know what is the probability here. All I have to do is take my 4,950 divided by my 14,900, and that will give me a percentage. And if that percentage is a good percentage, then the doctor is on the right track. But if it's a bad percentage, then he's probably potentially wasting his time. So we'll see. When I divide these numbers, I get 0.33. Turn that into a percentage and I get 33%. So that means that a doctor who decides to treat anyone who tests positive for the virus, 33% of the time, that person actually does have the virus. That means that 66% of the time, the doctor is treating somebody who does not have the virus. So that's not a very good percentage. 33% is a pretty low percentage, and so as a result we can say that the doctor probably should find a new test, or maybe not treat everybody that tests positive, because once again, there are people that don't have the virus that are still testing positive, so there might be a faulty in the test. Who knows what it may be. So that's how you do these problems. Once again, it takes a while to figure out the chart. That's going to be the hardest part. Once you have the chart figured out, the rest of it will be a little bit easier, but it's just getting that chart down.